Welcome to my channel. In this video I'm going to talk about the Numpy arrays, and this is going to be the second video on Numpy implementation. In this video I will talk about how to create Numpy arrays in different ways, and also I will show how to create random arrays. So let's get started. So first of all, as always, I should import the library. What was the name of the library? Numpy, and the abbreviation NP. And the first way to create an array is using the function called arrange. Suppose you want to create an array between -10 and +10, and you say the difference between the elements of the array should be, for example, 0.5. So in this case, you will use np arrange function, and you write np arrange, and it has certain parameters. As you can see, start, stop, and step. These are the important parameters that you should assign to this function. So you say I want from negative, but you can see values are generated within the half open interval, start, stop, which means the first element you assign as a parameter will be included to your array, for example, -10. But if you write from -10 to +10, the 10 at the stop value will not be included. If you want 10 in your array, you should write 10 point something or 21, 10.1 or 10.5. But if you write 10.5, so if you write more than like 10.6, 10.5 will be included. That's why it should be less than 10.5. And you will write from -10 to the 10 point something, not greater than 10.5, because if you write 10.6, 10.5 will be included as well. 10.1, and my step will be 0.5. And let's see what we get. So you can see, as I said, I have -10 and +10 that are both included to my array, and the difference between the elements of the array are 0.5, -10, -9.5, all the way up to +10. So let's see what we have as a different method. So let's see the different scenario. For example, you want to create an array that contains elements between -10 and +10, but you don't know the difference between the elements, but you want to have an array containing, for example, 20 elements in this range. In this case, you will use different function. It will be array np, and the function is called line space. And let's see what parameters we have. It has start, stop, that are both included. So in this case, it should be included because you do some calculations, like from -10 to +10, and you want 20 elements. You do some certain calculations in your brain, and you say that's why the difference between the elements will be like that. If you write 10.1, so it will not be very good. That's why, so you have to include both parameters from -10 to 10, and you say I want 20 elements in my array. And let's see what we have in the array. So you can see from -10 to the +10, and the both elements are included into my array. So that was the second method to create an array. Now let's see how we can create random arrays in Numpy. So how we were creating a random list in Python previously. So let's see, in this case, additional library should be imported as well. The library, what was the name of the library? It was import random, correctly, as you guessed. And I run it, so it runs perfectly. And I will use list comprehension to firstly show how to create a list containing random elements, maybe integers, between certain range and with a given number. So how to do that? So I write list, so I avoid writing list because it will be confused, because list is already data type name. List, and I use list comprehension, and I didn't import the name of the functions, that's why I should write the name of the model or library, in this case run it from -10 to the +10, and both will be included as I remember, for in range, and maybe you want 20 elements. And let's see what we have inside the list. So you can see we have tens, we have, let's run it for the second time. So you can see -10, so I run it to see -10 as well. So -10 is also included, +10 is also included, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, I have 20 elements in my list. So let's see how we can create the random arrays directly using Numpy. Of course, from here we can convert the list into Numpy array, but of course this method is not efficient, and also I will have to create an additional list that will take much more memory. So I don't want this case, that's why I will use the direct method. So let's see how we can do that. First of all, maybe I will use the random and to generate numbers between 0 and 1 with the given shape or size. Let's see. mp.random, and I don't need to write the range because it knows already the value should be between -1 from 0 to 1. So I should include the size. In this case, size is regarded as a shape. For example, I'll write the size of 10, and let's see what I get. Oops. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What if I write 4, 5 as size? Oops, you can see the matrix that have 4 rows and 5 columns. We can do another method, 20, and I want to reshape it. I want to write the shape 4 and 5. If I get, yep, the 4 by 5 matrix that I've created. Let's see how I can use the same method to create the array containing integers. R is mp.random. If we have the same, run it, yes. You write the boundaries between 20, between 10, -10, 10, and you write this size or the shape, or you can write a d type, but it will be integer. Maybe 20. Yep. Let's see if we can do matrix form. Yep, it works perfectly. I can do uniform, and I get floating point numbers. So that's good. There are another function called rand, which is not random. It's the same, but in the random, for example, I will create another array. The shape of 4 and 5, and I want to print out the array. And you can see the shape I wrote in the brackets, but I will do a different method. mp.round, and it will be the same, but I will not use the brackets. I will do just like that, the parentheses, and yep, I got 4 by 5 matrix. And now there is one more way, as far as I remember. So it's round n. But in this case, the output will be the normalized random numbers. So let's see, and you can see they usually should be from -3 to 3. You can see 1.3. Let's run it one more time. If we can get yes more than 2, bigger numbers more than 2. One more time. Yep, we have bigger numbers, and this is the normalized, and we'll see in the normal distribution, Gaussian distribution, in the following videos. So that's it for today's video. I hope the video was helpful for understanding the random arrays, and also 2 different ways to create Numpy arrays with a given range or with a given number of the elements. So see you soon. Thank you.